All right, I hope you guys have been well. I have gone ahead, I haven't filmed for a while because I purchased two new lights. They just came in. Maybe I'll make a video about them in the future for people who are interested, but I decided just to tell you about it in this video, which is the 2019 10B problem number 18. This light over here, it does reflect on the board a little bit here, but I consider that acceptable. The one over on the left over here is only on the wall. But I think it's greatly improved the camera's ability to function properly with better lighting. So I'm looking at the screen, starting out the camera, because I'm trying to see how it looks and stuff. Anyhow, hope you like it. In the future, I will probably add one of those, like, buy your teacher a coffee kind of links down below. I'm really close to partnership now, so I'll probably have that in the next, about a month from now, I would say. Anyhow, let's get started on this problem. 2019 AMC 10B problem number 18. Henry decides one morning to do a workout. This is a long problem, one of the longest ones I've seen from my recollection, long writing anyway. He walks 3/4 of the way from his home to the gym. So the gym is 2 kilometers away from Henry's home. At that point, he changes his mind and walks 3/4 of the way from where he is back toward home. Let's kind of set this up in the small space I've left myself for solving. So you're going to have home, right? And we're going to have some kind of distance. The gym will be over here. I'll put the point here. Well, there's going to be 2 points. We'll get to that part in a second. It's 2 kilometers, right? So when he reaches that point, he changes his mind again and walks 3/4 of the distance from there back toward the gym. So he went 3/4 of the way to the gym, 3/4 of this distance back towards home, stopped at that point and went 3/4 of that distance back to the gym. He's going to keep doing this. If Henry keeps changing his mind when he has walked 3/4 of the distance toward either the gym or home from the point where he last changed his mind, he will get very close to walking back and forth between a point A kilometers from home and a point B kilometers from home. What is the distance between A and B? When you read things like this, don't read them always for their face value, the absolute value of A minus B. Read it for what it is. The absolute value of a difference between points is the distance between those points in geometry. So always try to convert the way they write things into different ways to think about it as you read. Okay, so we're going to call the points here A and the point over here B. Now before we get into the fast way, the proper way to do it, there is a bashing method, right? The bashing method is long and tedious. It will probably take you 5 to 6 minutes to do, and that's fine if you have enough time. So how do we decide that? Well, let's say you've answered 1 through 17 and you're pretty confident in all the answers and you've got 12 minutes to go or 10 minutes to go, and you've already looked at 19 through 25 and they feel like they're going to take a similar amount of time to you bashing this problem. Well, if you know that you can bash this problem and you will get it correct, then go ahead and invest the time. Getting 18 right in a modern era test, if you got none wrong, or even one wrong, gives you a really good shot to qualify. But if you only answered 12 of the first 17, maybe don't bash it and look at 19 or 20, or look back at earlier ones that you skipped and thought you would return to. It's kind of a judgment call depending on where you're at. I'm not going to bash this out, but I am going to show you how you would start something like that. You can consider the point here 0 and the point here 2, and B is the distance away from 0, home. So if B would be, well, the first time he stops, right, he's going to stop at the point 1.5. In fact, let's call it 3/2, because that is 1/4 of 2. So then, or 3/4 of 2, right, 6 over, yeah, if I do 3/4 times 2, the 2 cancels, you get 3/2. So anyhow, then you're going to head back towards home from this distance, right? So this is like your first stop. And then second stop, you're going to do the distance of 3/2, which is how you would be from about where B is, not quite. About where, say, in your mind, just use B, but it's not really at B. That distance to here, he's going to go 3/4 of it, which means the current distance is 3/2. I need to subtract 3/4 of 3 over 2. Right? So when he's gone 3/4 of 3 over 2, that would be this distance in between, he's going to have this much space left. This would be where he was at after his second stop and then about to change his mind again. Right? So 3 over 2 here minus this distance, which is 3/4 of it, leaves him whatever that is. And it's not A, but you can kind of conceptually use it. And you can just keep going in this process. It starts to get crazier and crazier fractions, and they're really big, and you're going to have to do some decimal division before you can figure out which of these it is between this one, and this one. You'll pretty quickly figure out it's one of these two. They're really close, 1.2 and 1.25, and you'll have to go far enough till you've convinced yourself that which one is correct. Okay, but we're not going to go that route here, but just so you are aware of its availability. So then, how can we do this? There is kind of an assumption that you want to make, but we'll get to that in a second. The distance from 0 to B would be whatever B's location is, right? And we can say that A's value, right, if I do B minus A, right, this is B minus A, that would be the distance between A and B. I don't need absolute value because in my problem, B is greater than A. They put it because they're leaving it up to you. You could have put B here and A here if you wanted. Okay, so B minus A, what is that going to be? It's going to equal 3/4 of B's distance, right? Approximately, right? After they settle in, the points are zoomed in on after, an almost infinite number of ways to do that, of iterations, if you will. It would settle upon this reality. Okay, the next thing we have to do is we have to kind of make an assumption, and I couldn't figure out how to establish this as guaranteed to be true. It feels logical and intuitive to the experienced test taker, but perhaps, there might be a way to prove it. If you know a way to prove it, leave it in the comments, but you should kind of sense this reality. And that is that the distance from home to A is the same as the distance from gym to B, that it's going to be symmetric, right? And once you've done that, you can say that A is going to equal, or even B, the distance of B, well, yeah, let's just do A. A is going to equal 2 minus B, right? So if I take the distance of 2 and I subtract B, I will have this distance left, right? That distance is equal to this distance by symmetry. Again, you kind of have to take it as an assumption, but it just kind of feels logical and right. Don't always trust assumptions, but in this case, if you want to get it right in a fast manner, you might have to do so. Then, from here we have a system of 2 equations and 2 unknowns. We can just solve it. I'm going to move 3/4 of B over here to get 1/4 of B and the A over there to get A. Now I can plug this into here and add B over here to get that 5/4 of B, because A is 1/4 of B plus 4/4 of B is 5/4 of B, is equal to 2. Multiply by the reciprocal to get 8/5. All right, so now we know 8/5. Just kind of plug it in. If I take 1/4 of 8/5, then I get A is equal to 2/5. If I subtract those, I get 6/5. That is equal to 1 1/5, and that's the answer C. One last note to make about this. I feel like there's probably a limits way to do this. My ability to apply limits to a difficult problem isn't so high. I mean, I can do limits for calculus and stuff like that, but you might want to look into it. If you have the time and the willingness, try to find a way to do this with limits. If you ever find a way and you do a video on it or an explanation on the AOPS website, go ahead and leave a comment down below. I'd love to read it. I'll see you guys in the next one.